Hey everybody, let's get into this video. We are on the fourth video in this whole playlist, and if you haven't watched the other videos, I do a lot more explaining of the process, so I definitely recommend you go back there, especially the first video where I go over local behavior. And if you need help with factoring or anything else, you got to go find the playlist for that. This is not the place. This is for graphing polynomials. Let's go. First step in our graphing polynomials is, well, without saying, you want to make sure if it's expanded and not factored, that it's at least in standard form when you're looking at it. We're going to go ahead and figure out on the side our end behavior, and the end behavior is determined from the leading term. So since my leading term is 7x squared, my end behavior will be up and up, up and up. This up is because it was positive leading term, and this up is because it was an even degree. So up and up, it's up on both sides. There we go. Next thing is to figure out, to put it into fully factored form. So factor, I have my steps. I go through them in the first video. Factor everything. I'm going to start by taking out my GCF. So I have f of x equals, my GCF is 7x. You want to make sure it's really factored correctly. You're going to have trouble if you're not fully factored and you're not factoring correctly. You're going to confuse yourself. If I factor out 7x, what's left here is x minus, divided out, right? Because distribution is multiplying, so factoring is dividing. Minus 4. We're done. That's fully factored, I promise. After that, z is for the zero product property. So we're going to go ahead and we're really setting f of x, which is y, equal to 0 to find x-intercepts. Zeros is another name for x-intercepts. And we do that by setting each factor. 7 doesn't really count as a factor. It's being multiplied. It's a vertical stretch. Again, that's a conversation for a different day. But x gets set equal to 0 and x minus 4 will get set equal to 0. The largest exponent is the maximum number of x-intercepts you can have. So if you're finding more than 2 in a case like this, like you're confused. You're messing up. So the 7, don't worry about that. So setting each factor equal to 0, you get x equals 0, and we get x minus 4 equals 0. So x, add 4 to the other side, equals 4. So here are my 2 x-intercepts, or zeros. After that is A for axes, which I already have set up for us right over here. Then we're going to do some plotting and labeling. P and L are the next two. So we're going to plot these and label them with their local behavior. Plotting and labeling. So if I plot them, I have 0, label that as 0, and I have 1, 2, 3, 4, label it with a 4, but I'm also going to label it with local behavior. How does it behave at 0 and at 4? Well, the way we find out, again, it's explained in the first video, they're both going to be linear. If you don't know why I did this, why didn't you listen to me in the beginning and go watch the first video? Y equals x cubed minus 4x. I explained it all there. Go. Get out of here. Goodbye. So they're both going to be linear. So a little L and a little L gets labeled on here as well. And more another L. So now what do we do? Well, my end behavior was up and up. So I am going to have some arrows up and up on either side of my rightmost and leftmost zeros or x-intercepts. What's our insurance policy? What do we talk about? What's the insurance? We start drawing on the right side. If you don't know that, I don't know why you don't know that. I explained that in the second video. So we start on the right. I explain why. We're going to work our way here. That's an x-intercept. Now, x-intercept doesn't mean you have to cut through the x-axis. You could touch and go. You could cut through in a special way, do a little dance when you cut through. But this is linear behavior. So we're going to cut through and look pretty straight through like this. But polynomials, as we know, smooth, curvy, continuous. We could draw them without picking up our pencil. So I'm going to have to turn around to get my way over here to the next x-intercept. It's also linear. Oh man, Dallas is not having it again. He is just so fussy today. So not my best drawing, but it's going to be pretty straight, okay? So forgive me, guys. I'm not impressed with my own work here because I'm trying to force it through and make it straight. Ew, it's still so ugly. I don't know why I'm like this. I don't know. Turn this. Okay. So now we're going to cut through again quite straight. Shoop. and it's going to look pretty linear, but the whole graph should be curved. You shouldn't have sharp edges anywhere. If you do, you're not doing it correctly. In calculus, you'll learn about differentiability, and that's an important quality of polynomials. So there you have it. That is the graph of this. Yes, I am perfectly aware that it is a quadratic or parabola, and you could have found the vertex with x equals negative b over 2a and all that other stuff. But Dallas said he wanted to do it by graphing polynomials, and he thought it was a very good idea to show you guys this example, because guess what? Sometimes your vertex is an annoying fraction, and Dallas doesn't want to deal with that because he said you guys mess up fractions when you plug them back in. So look at that. We avoided them. Okay? Thumbs up for puppies and polynomials, and thumbs down if you're dead inside. And there's a playlist. There's another video after this. Keep practicing. It's the only way you're going to get better at it. Sayonara.